Hello and welcome to this R tutorial. So let's pick up where we left off. That is, let's try to figure out why we're using this upper bound equal to this very large number 10 at the power of 400 given to this upper bound variable here in this else condition. Well, let's see what happens. Let's see what happens at first round. Well, at first round, we will go through the 10 versions of the add thanks to this for I loop here. And since at the first round, no add was selected, well, this condition here, if numbers of selections I is higher than 0, will never be true. And therefore, we will directly go to this else here. And accordingly, the upper bound will be set equal to 10 at the power of 400. Then we move on to this condition, because this is the next step of this for loop here. And it says that if upper bound is larger than max upper bound, which is true, of course, because upper bound is 10 at the power of 400 and max upper bound is 0, so this condition is true. So what happens next is that max upper bound is equal to upper bound, so max upper bound will be equal to 10 at the power of 400, and add equals I. And so since we're at the beginning of the for loop here, I equals 1, so add will be equal to 1. And then what happens? Then we go to the next step of this for I loop here, which is I equals 2. And I equals 2 corresponds to the second add. And the second add hasn't been selected yet, so numbers of selections I here will not be larger than 0. So this condition will not be true here. So again, we will go to this else here. And therefore upper bound will be equal to 10 at the power of 400. And then we go to this if here. So now let's see if this condition is true. Upper bound is equal to 10 at the power of 400. And remember from the previous round, max upper bound was set equal to 10 at the power of 400 because it was set equal to upper bound. So this condition translated in real terms is if 10 at the power of 400 is larger than 10 at the power of 400. And that is not true. 10 at the power of 400 is not larger than 10 at the power of 400. So that condition is not true, and therefore add is not set equal to 2 because right now I equals 2, but it remains equal to 1. And that's why at the first round, the add that will be selected is add equals 1. That is the first add. You can try with the other values of I here. Upper bound will always be equal to 10 at the power of 400, and max upper bound will stay equal to 10 at the power of 400, so therefore this condition will never be verified for the 9 remaining adds here, and therefore we keep this add equals 1. And that's the same principle for the next rounds, up to 10. At round n equals 2, this numbers of selections I here will be larger than 0 only for the first add, because the first add was selected at round 1, and therefore this condition will be true only for the first add. So upper bound will be equal to this average reward plus delta I here. But then we'll move on to I plus 1, which will correspond to add version 2. And since add version 2 wasn't selected yet, well, this numbers of selections I here will be equal to 0, and therefore this condition won't be verified. And therefore we will go to this else here, and upper bound will be equal to 10 at the power of 400. We will forget this upper bound value here computed at the previous I here. And therefore what happens next is the same. Upper bound will be larger than max upper bound because max upper bound was equal to the upper bound at the previous I, and the upper bound at the previous I was average reward plus delta I, which is of course lower than this 10 at the power of 400, and that's why, by the way, we set it to a very large value. It's in order to have this upper bound here lower than this 10 at the power of 400, and therefore max upper bound will be 10 at the power of 400, and we will select add equals I, that is add number 2. And then, same principle as before, when we'll move on to the next i's, upper bound will be equal to 10 at the power of 400, max upper bound will also be equal to 10 at the power of 400, so this condition won't be verified, and therefore we will keep add number 2. So that's why this nice little trick here works perfectly well for us and gives us exactly what we want. Alright, so the 10 first round select the 10 adds, and then after round 10, we use this strategy to select the adds. Alright, so now the only thing that we need to do is to append the selected add here in this add selected vector here, and that's exactly what we'll do now. So let's do it. We just need to get out of the for I loop because we're done with this loop. We did exactly what we had to do, that is to select the right add, and now we need to get out of this for I loop, but remain in this for n loop because we are still at a specific round n, And what we have to do now is to append the ad that was selected here to this huge vector ad selected that contains all the different ads selected at each round. Okay, so now things are easy. We just need to use the append function on this ads selected huge vector and then append, here it is. All right, and now in this append function, we enter as input, first input ad selected and second input ad, because it corresponds to the index of the ad that was selected in this for I loop here. All right, so done, ad appended, and now since we've just selected a new ad here, what we need to do is to update this vector number of selections here, that is, the vector telling for each ad, the number of times it was selected. So since here we know which index of the ad was just selected, what we need to do is to add a +1 in this particular index of this numbers of selections vector to update this vector. So let's do it right now. We will stay, of course, in this for n loop because this vector will contain the numbers of times each ad was selected at this specific round n, so we need to stay in the loop. And we will simply take this vector here, copy, and paste it here to update it. And so what we need to update is the ad index of this numbers of selections vector, because this ad index corresponds to the index of the ad that was just selected here, a selection that is based on all this strategy. And so what we simply need to do is increment by 1 this vector here. So we will copy that again, copy, equals, paste, and then a little +1 here. All right, so now this numbers of selections vector is well updated. And that's all we need to do for this vector at this specific round, because of course, only one ad was selected. Okay, and now we need to take care of the rewards, because indeed we have this sums of rewards vector here that we need to update, because this vector contains the different sums of rewards of each of the 10 ads at each round. So we need to update it. And of course, afterwards, we would like to get the total reward that, will be a variable containing the unique sum of rewards we accumulated over the n rounds. So let's first take care of this sums of rewards vector here, and then we'll take care of a total reward. So to update this sums of rewards vector here, what we need to get now is the reward we get at this specific round n. Because, we just selected this ad here, but we haven't got its reward yet. We just selected the ad so far. Now we need to get the reward. So in real life, what happens is that, we show the ad to the user, and then the user clicks yes or no on the ad. But here we're not in real life. As much as I would have loved to show you a real experiment of this right now in front of your eyes, this would not be that simple. But we have this simulation data set, this data set here, that, contains the real results only known by God, because we have no idea of which ad each user would click on. So as a reminder, the first user clicks on ad 1, ad 5, and ad 9, not the rest of them. So that's just a simulation data set. And so what we have to do now is get the reward at each round and based on the ad that was selected, thanks to this data set. So let's do it. What we'll simply do is get the reward that is either a 1 or a 0 at this specific round n where we are at. And so to get this, it's really simple. What we need to do is, take our data set, and in the brackets, we'll need to specify the index of the line where we are at, which is, the round n corresponding to the round where we are right now. So since all the lines of this data set here are nothing else but the rounds, well, the first index will be the round. So for example, let's say we are at round 9. Well, we will need to take the line index 9 of the data set. And then for the column, since the columns here correspond to the rewards of the 10 different ads, well, we will need to take the index of the ad that was selected. That is nothing else than this ad index here. So that's the idea. That's what we have to do. But of course, in real life, you'll get what really happens with the users. So I'm going to close this. And right now, I'm going to get the real reward at round n that we get with this selection of this ad index here. So let's do it. We will call this real reward simply reward. All right. And now, as just explained, we need to take the data set and then brackets Then we need to take the index of the line that corresponds to round n, so n here, and then we need to take the index of the column that corresponds to the index of the ad that was just selected. So it's add here, and that's all. We simply get the real reward at round n for the specific selection of this ad by using this. Okay, so great. We've just got the real reward, and now we can update this sums of rewards vector here that, as a reminder, gives the sums of rewards of each of the 10 ads at each round n. So we will take this, copy, and then just below we will increment this vector. And of course we need to take the ad index of this vector because only the ad that was selected at this specific round n will have its sum of rewards changed. So that's the only sum of rewards we need to update. And therefore what we need to do is to increment it by the reward, not by 1 of course, only by the reward because the reward is either a 0 or a 1. So equals here, and then we take that again, and then plus reward. So if we got a 0 reward, the sum of rewards for this specific ad won't change, and if the reward equals 1, this sum of rewards for this specific ad will be incremented by 1. Okay? And now we just have to do one last thing. It's of course to get the total reward accumulated over the n rounds. Well, the total reward is not very interesting for us at any round n, but at the last round n, that is at the 10,000th round, because we will compare it, of course, to the total reward we got with this random selection algorithm, which, as a reminder, was 1,200 on average. So that's why we're very excited to find out about this total reward, but at the end of the 10,000 rounds. So, of course, we need to initialize this total reward variable because, we are updating it at each round. So we need to give it initial value like in physics. And this initial value we'll give is, of course, 0 because at round 0, at the beginning of this experiment, the total reward is, of course, 0. We haven't accumulated any reward yet. So let's declare this new variable total reward right here and then set it equal to 0. And now, very simply, what we need to do is to compute the total reward that we accumulate at each round. And very simply, we need to do another increment, the same as the one we just did. So I'm copying total reward here, pasting it here, and equal, and then paste it again, and adding a plus. And then according to you, what do we need to add? Of course, we need to add the reward that we get at each round n. And that's done. The UCB algorithm is implemented. Congratulations. This is the first algorithm we implement from scratch in this course. That's very exciting. And as you notice, we built and implemented this algorithm as if we would do it in real life. We didn't add the lines one by one. We implemented it as a developer would do it step by step, with the same logical thinking process. So congratulations, and now I'm so excited to look at the results and find out by how much the UCB algorithm will beat the random selection algorithm. So as a reminder, the random selection algorithm gave us a reward of 1,200. Let's see how UCB beats that, and let's hope we get a nice result. So I'm going to select everything from here to here. All right, and there we go. Here it is. Let's immediately have a look at the total reward. We can see that the total reward is 2,178. We almost doubled the total reward earned by the random selection algorithm. So that's great. If you are the casino and if the ads are not ads, but, slot machines, that means that you would earn twice as much money. And that's not all, because this is just the total reward of the experiment. But what's very interesting to see now is the specific ad that has the highest conversion rate, simply what is the best ad to show to the users. And how can we find out about this? Well, what we simply need to look at is this ad selected vector here. So let's have a look. First, what we can see is that as expected, as the expected result of our implementation here, well, we can see that during the 10 first rounds, the 10 ads are selected. Round 1, we select ad 1, round 2 at 2, round 3 at 3, up to round 10 at 10. So that's exactly the result of what we did here with this huge value trick to get this 10 ads at the 10 first rounds, and then the strategy starts. Since we get some informations based on the selections of these 10 ads here during the 10 first round, then we get the sums of rewards info and the numbers of selections info, and that's when the strategy can start. And that's exactly what happens here. From here, the strategy is running and different selections appear. And what's really interesting to see now is to look at the last rounds, that is, the rounds close to 10,000, because if this strategy works, well, logically, this algorithm should select always the same ad during the last rounds, because there is one ad that is the best, that has the highest conversion rate. Maybe it's the ad where the car is on a beautiful bridge. So there is this winner ad that we don't know, of course, but that what this ad selected vector will tell us if we look at the last round. So let's do it. We will go down and down and down. Okay, here we go. So as you can see, as I'm going down, it appears that there are more and more 5 at the different rounds. As you can see, there are more and more 5 that we're selecting at each round. And if I go down again and go down more and more, well, we get even more 5. And at the last rounds, that is during the last 1,000 rounds, well, we select only 5, as you can see. Right now we are at the round 9,800 and we can only observe 5. So clearly, the best ad that we should pick to show to the user and that has the highest conversion rate is ad number 5. So great! Not only we almost doubled the total reward with this 2,178 total reward, but also we get to know what is the best ad to show to the users. And of course, we're interested in both. We're interested in knowing what's the best ad, but also to optimize this total reward here, because, experimenting this placements of these ads on the social network costs money. And, as said at the beginning, we have a limited budget. And that's generally the case for departments of marketing or any business. We have a limited budget, so we need to optimize this total reward here to compensate the costs and hopefully already earn some money. So these two results are very important. And so thank you very much to this UCB algorithm. And now, as usual, as promised, we will finish this UCB algorithm section with the last step, the exciting step about visualizing the results. And simply what we'll do is plot a histogram showing for each ad the number of times it was selected. So we'll do that in the next tutorial, and until then, enjoy machine learning!